Welcome back. In the last few classes, we are looking at perception of depth and motion. In this class, we look at the psychophysical aspects of the perception of motion and depth. As we know, psychophysics is a relation between the stimuli and the perception. We will focus on deriving a relation between physical properties of the stimuli and the depth perception and motion perception. So we'll start looking at the depth perception, and we will start relating that depth perception with the stimuli properties such as the contrast and spatial frequency. What is that relation is what we are going to examine in this lecture. At the end, we are going to look at how this psychophysical relation can be useful in designing a better virtual reality systems. Before we start our discussion, let us look at a couple of terminologies. One terminology is depth perception, depth discrimination. Discrimination threshold. This is defined as the smallest depth that can be discriminated. So if we have an object in the space, and let us say this is the eyes, we have the distance between the eyes is a, and we have an object at a distance, let us say d distance, and this distance is del d. What is the smallest distance that we can discriminate? That is a depth discrimination threshold. This is also referred as a stereo acuity. Stereo acuity. This is a discrimination threshold. Threshold when binocular disparity is the only cue to perceive the depth. As you have seen in the earlier lectures, there are many cues for depth discrimination. So the depth discrimination threshold will involve all the cues, but in the stereo acuity, we will restrict the depth discrimination cue only to the binocular disparity. That is a stereo acuity. We can write a small expression also. Stereo acuity is nothing but is proportional to a times del d divided by d squared. This is in radians. As d increases, the stereo acuity is inversely proportional to the square of d. As stereo acuity is proportional to the distance a, and then proportional to the del d also. So with these two terminologies, there are more terminologies required, but we will restrict to only these two terminologies. Let us look at how stereo acuity is related to the contrast. How stereo acuity related to contrast. In a graph, if you plot contrast in x-axis, specifically we are talking about the contrast threshold in terms of the multiples of the thresholds. Let us start with the 1 contrast, and then let us plot the things in log graph. Let us say this is 10 and this is about 100. Then there is a relation between contrast sensitivity and the stereo acuity. But there's a nonlinear relation. So at about let us say this is about 5 and this is about 50 in the log scale. Until 5 times the threshold contrast, the relationship seems to be square root. After this, the relationship seems to be cube root, and then this is going to be constant. So this graph shows that at very high contrast, the stereo acuity is independent of the contrast. At medium contrast, that is from 5 times to 50 times the threshold, the relation seems to be cube root. It means stereo acuity is proportional to the cube root of contrast. At below 5 times the threshold, that's a very low threshold, stereo acuity is proportional to the square root of contrast. So when we are designing VR scenes, very low threshold objects look further when compared to the objects with a higher contrast. So low contrast, let me write it down, low contrast stimuli appear more distant than high stimuli, high contrast stimuli. You need to be aware of this. Now the question is that we know the contrast is also a function of the spatial frequency. Can we now relate the spatial acuity to the contrast and the spatial frequency? As in the earlier lectures, we have related the contrast to the spatial frequency in the contrast sensitivity function. CSF, spatial frequency in the x-axis, in the y-axis contrast sensitivity. We usually get a curve like this, and the maximum sensitivity is about 3 cycles per degree. This is for detection of an object seen in the normal screen. But when we see the same thing, objects, in a stereoscopic display where binocular disparity is in place, then the contrast sensitivity seems to be decreased. So this is for stereopsis. Stereopsis meaning the object seen using the binocular disparity. You can see that the same curve is actually shifted slightly down. It means the contrast sensitivity has pushed it down. It means it needs more threshold in order to have the same effect as the normal monoopsis vision. So there are a few things we can notice. First thing is that the stereopsis is not impaired by the contrast threshold. Stereopsis is not impaired by contrast threshold. That is because the curve is the same in both the cases, it's just slightly pushed. Okay, the curve is pushed because of the stereopsis, but the stereopsis itself, the shape itself, is not changed. That is the reason we are saying that it is not impaired by the contrast threshold. And the second thing is that objects in low frequency image looks distant. Then can we say distant? It needs more contrast. Okay, objects in low frequency image needs more contrast to perceive the depth, perceive the same depth. These are the implication of this psychophysical data. Now let us extend this to the motion, how this can be useful in looking at the motion data. It's the same CSF curve. Let us take it again, spatial frequency. This is a contrast sensitivity. Drawing the same CSF at 3 cycles per degree. One thing to notice that this CSF curve is for stationary objects. Stationary objects. If the object is moving, then at lower frequency there seems to be no fallen in the contrast sensitivity. This is for motion. This is for stationary. Whereas at the higher frequency, more than 3 cycles per degree, there is no change in the CSF curve when we are talking about the motion. Only at the lower frequency, it seems to be independent of the spatial frequency. So this may be due to the peripheral vision, where it is highly sensitive for the motion when compared to the fovea. So again, the implication of this data is that at very low frequency, motion, and we don't have to worry about the contrast. Whereas if it is stationary, then we have to worry about the contrast. We will stop here. Thank you.